We have some folks over here helping us out from the National Science Center today, Becky, Tessie, and Ollie, and I have challenged them to break an egg by throwing it into a sheet. Tessie was a really good softball pitcher several years ago, and so we're going to ask Tessie to accept this challenge first. Her challenge is to throw a raw egg hard enough into this sheet to break the egg. Tessie, let's get a wind up, the pitch, and did it break? Well, Tessie, that was a great pitch, but the egg isn't broken yet. Now, it's traditionally known that men have a lot of upper body strength that a woman doesn't have, so maybe Ollie can pitch the egg fast enough to make it break. Tessie, if you could hold the sheet for us, and Tessie and Becky will hold the sheet, and let's see if Ollie can make the egg break. Ollie's going to try to throw the egg in the sheet fast enough and hard enough to break it. Do your best, Ollie. Oh, right. Good pitch. Good throw. But the egg is still whole, still in one piece. Maybe I fooled them. Maybe this is not a raw egg. Tessie, let's try this. Just throw it gently up against the wall here, up against the cabinet, and ooey gooey egg all over the place. It is raw, and it did break. Now, I was kind of unfair to these folks. Actually, a major league pitcher who can pitch between 90 and 100 miles an hour can't throw an egg into a sheet hard enough to make it break. And yet when Tessie just tossed it lightly up against this hard surface, as you can see, it broke very easily. What's the difference? Now let's see the physics of what happened here. If you'll remember from earlier in our discussion, we were talking about Newton's second law, F equals ma. Force depends on two things, mass times acceleration. Recall, too, when we talked about acceleration being change of velocity over change of time. So we could rewrite this equation to say force is mass times velocity over time. And recall, too, that mass times velocity is what in physics we call momentum. So simplifying this equation, now we have force times time equals mass times velocity. Force times time is what is called in physics impulse. So what this equation says is that impulse equals momentum. Force times time equals mass times velocity. We've also seen that momentum is conserved. It isn't gained or lost, but it can be transferred to another object. If you'll remember the dynamics carts, the motion of one cart, its momentum was transferred into the second cart. Recall, too, that momentum, because it is conserved, will be transferred directly into the other object. And this is what happened with the egg. The egg had a good deal of momentum on it. It had a very, very small mass, but they threw it pretty hard. It had a pretty fast velocity. And as you recall, even throwing an egg at 90 to 100 miles an hour still won't break it. So we're looking at a really pretty fast velocity. So you've got quite a bit of momentum on the egg in spite of its small size. That momentum of the egg, when it hits the sheet, is not lost. Rather, it is transferred into the sheet. Look what happens to your force if you take the time and enlarge it. And that's the secret to why the sheet will not break the egg. The sheet gives. And in giving, the sheet causes the time of this momentum transfer to be quite large. If you increase the time, the force has to get smaller. Because momentum is conserved, this number would not change. The secret then to a lot of impacts and prevention of impacts is in the time that the collision takes place. When Tessie threw the egg up against the front of the counter here, you have a hard surface. So the time of the impact was very, very brief. The momentum of the egg is transferred now into the hard surface, but the time is the factor. The time hits so fast that you have a fairly large force. And so it quite easily breaks the egg. The egg will not break in a sheet because the time causes the force actually to be less. On a hard surface, the time is very brief, and so the force is large and easily breaks the egg.